One-on-one with the sun. This is a pretend interview with the sun. Hey, Stella Stardust here. Welcome to another cosmic conversation. Let's give a warm welcome to the sun. And we're going to look at our caption underneath the picture of the sun. It says, 93 million miles from Earth, a giant ball of hot gas brightens the sky. Nuclear reactions in the sun's core create energy which gradually flows to the sun's surface. The energy reaches the Earth in the form of sunlight. The sun's heat and light warm Earth's surface, drive weather and currents, and make life possible on our planet. We experience the sun's energy every time we feel its warmth on our skin or see with the aid of sunlight. Now to our conversation. Stella, you know everyone here on Earth loves your work. If it weren't for you, we wouldn't be here. Sun, thanks, Stella. I've been cranking out energy for billions of years, and not one day off. Stella, impressive. Your agent told me that you're the biggest star in the universe. Is that true? Sun, actually, no. My agent tends to exaggerate. I'm just a medium-sized star. To my fans on Earth, I look much bigger than the other stars in the sky. That's because I'm much closer to you than the other stars. I'm 93 million miles away from you. The bigger stars are millions of times farther away from your planet. Stella, I can't believe it. You, the sun, are just an average, ordinary, run-of-the-mill star? Sun, hey, take it easy. I may be an average star, but I'm still a lot bigger than your puny planet. Guess how many Earth-sized planets could fit inside me? Stella, I don't know, maybe 10? Sun, not even close, more than 1,000,000. I'm big and I've got lots of mass. That's why I've got a lot of gravity. You guys don't call this the solar system for nothing. Solar means sun. This is my show. All the planets, comets, and asteroids orbit around me. We look at our caption underneath our picture. Gravity is the force of attraction between objects in the universe. Objects with more mass have greater gravitational pull than objects with less mass. Gravity keeps Earth and the planets orbiting around the sun instead of floating off into space. What would the universe be like without gravity? Back to our conversation. Stella, I know you star types tend to be touchy about age, but how old are you? Sun, well, I began shining about 4.6 billion years ago. It was so long ago, I don't remember the exact day. Stella, was it a Sunday? Just kidding. Actually, I'm curious to know how stars begin. What's your story? Sun, we stars begin as huge spinning clouds of gas and dust. Gravity pulls the gas and dust together in round clumps, which get hot. At that point, we're called protostars. Eventually, we get hot enough to start fusing hydrogen atoms together, which releases energy. Then we really shine. Stars are born in batches, which are like star nurseries. Then, over millions of years, these stars drift apart and spread out around the galaxy. Stella, let's turn to a delicate subject. How do stars die? Sun, after stars like me shine for billions of years, we eventually run out of fuel. When that happens, we swell up as much as 100 times bigger and are called red giants. Astronomers predict that I'll eventually become a red giant. At that time, my heat will vaporize the inner planets, Mercury, Venus, and Earth. Stella, well, that sounds really scary. Sun, don't worry, that won't happen for about 5 billion years. After I become a red giant, I'll lose my outer gas layers and reveal my inner core, known as a white dwarf. When I'm a white dwarf, I'll only be as big as Earth, but still very hot and very dense. Finally, I'll cool down and disappear from view. Stella: I hear that some stars die differently. What's a supernova? Sun: When a star more massive than I gets old and runs out of nuclear fuel, it blows up in a great flash of light called a supernova. This explosion splatters the star's guts in all directions. If we look at our picture, about 1,000 years ago, a massive star exploded at the end of its life cycle. What remains is called the Crab Nebula, a glowing cloud of gas and dust. At the center of the Crab Nebula is a pulsar, the small spinning core of the massive dead star. The pulsar emits all kinds of light, making the Crab Nebula easy to detect with a telescope. Back to our conversation. Stella says, I'd like to show people at home a picture of a star that exploded as a supernova. Its remains are called the Crab Nebula. Sun: What a mess that star made. Want to know something amazing? Humans saw this star explode in the year 1054, but the explosion actually happened about 6,000 years before that. Stella: Huh? Sun: I'll explain. Stars give off light, right? Light travels incredibly fast, at a speed of 186,000 miles per second. Light can travel from Earth to the moon in about 1 second. My sunlight reaches you Earthlings in about 8 minutes. Most stars are much farther away. That's why astronomers don't use miles when they're talking about the distance between stars. That's like describing the distance between New York and Los Angeles in inches. Astronomers talk about light years. A light year is the distance light can travel in 1 year. Since the star in that picture was about 6,000 light years away from Earth when it exploded, it took about 6,000 years for us to get the news flash. Stella: In Hollywood, I meet a lot of people filled with hot air. What gases are inside of you? Sun: Ah, you want to know what gives me that special glow? Well, like most other stars, I'm made up of mostly 2 gases, hydrogen and helium. These light gases stay close to me because of my massive gravity. Inside, I'm so hot that I use a fancy process called thermonuclear fusion. By turning hydrogen into helium, I create lots of energy. It makes me shine. Stella: This may be a little rude, but what are those dark splotches on you? Are those like star zits? Sun: No. Those dark splotches are called sunspots. All normal stars have them. They look dark because they are cooler than the gases around them. By the way, when I say cooler, keep in mind that my outside is about 10,000 degrees Fahrenheit. That's many times hotter than the hottest kitchen oven. My inner core is even hotter, something like 30 million degrees Fahrenheit. Stella: Is there anything else you'd like to say? Sun: You think your sunglasses are star-shaped, right? Stella: Sure. Well, if they really were star-shaped, they'd be round. You Earthlings have the strange idea that stars have points. We don't. Gravity keeps us shaped like spheres. Stella: Thanks to the sun for a great interview. Good night.